Right, welcome to part 2 of Code Signal Arcade. On the part 1, we have done problems 1 to 13, and then now let's move on to starting from problem 14. All right, so what's this saying? Several people are standing in a row and needs to be divided into 2 teams. Okay. The first person goes to team 1, second person goes to team 2, and third person to team 1, so forth, so forth. Okay. Just waiting for the people. Okay, I guess we're just summing these people up on the odd positions. Okay. So basically, like, the problem is you have a list of numbers, and then every odd numbered position, like first, third, fifth, goes into one group, and then sum them up, and then even numbered positions, and also same thing, sum them up, and then return like a two-sized array. Okay, so it's a pretty simple problem. Let's just create a. I guess we can create something like this. Result equals like 0, 0, because that's going to be our return to number, right? So then we can just loop into the list, and then I can get the index as well. So enumerate and then, well, I guess we don't really need the index. We could just have like a toggle or something, but I think index is fine. So if I choose 0, that means it's the first index, 0th index, second index, and blah, 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 right? So we're just going to add it to the first one. And then if it's not, then result of 1 equals that. And then we just return the result. Simple as that. So basically, there's no extra space on here. There's just O(n) time complexity, right? So let's move on to the next problem. Okay. All right. So I think the idea is just put asterisk character like around the border of each sides, right? So basically top, bottom, and then left and right. Okay, so adding it to the top and bottom is pretty self-explanatory, but I guess let's start off with like getting the row count as well as the column count, because that's always a good idea. Wait, is it gonna be the same? Rectangular matrix. Okay, it is gonna be the same. Okay, gotcha. So yeah, picture, and then I guess do we need the column? I guess we do, kind of, but not really. Okay, let's just do that. Okay, so the result would be like, so let's just add the top first, right? So this is gonna be like the top edge of asterisk. So it's gonna be like that times. So in Python, you can actually multiply a string. So that's gonna be just like this times how many characters, right? So we have 5 in here, which is column plus 2, right? So let's just do the column then. Length of picture of 0, call plus 2. So that's going to be the top. And then we can loop through each row of the picture. Yes, be in picture, and then result.append. I can add it first, and then add the p, and then add the star next to it. So we just need to add one star at the end, one star at the beginning, right? So that's what we're doing. And then again, at the end, we append this thing, and then simply return it. Oops, I think I results. Okay, let's just check this real quick. Okay, that's good. And obviously in here, there's going to be a extra space complexity, right? Because we're returning this thing. So essentially, the time complexity and space complexity is going to be both O(n), and n is like the size of the picture along with its characters, right? So that's going to be that, right? So you can always say like it's O(n) times m also, like n is going to be the number of rows and m is going to be the number of columns. You can also say that. So Okay, next question. Are similar, okay. Two arrays are called similar if one can be obtained from another by swapping at most one pair of elements in one of the arrays. One pair, okay. At most, okay. If they're equal, then it's automatically the same. And the output should be true. So in here, the output should be true because we can just swap these two to get the number, right? Okay. In here, the output should be false because the numbers are not the same, right? Okay. All right. So I think in here, what we can do is like check the numbers, the positions respectively, but we also have to check the swapped version as well. I guess let's just do this. We have a count of 0, and then we check each number respectively at the position, right? And then if there are different, then we just increase the count. So let's just do that. I in range, length of A. And then if A of I is not equal to B of I, and then we increase the count, right? But if the count is like greater than 2, then we already know it's false because there's just no way that we can just swap two numbers and then get the same array, right? So this is instantly false. And then return true at the end, but there's also going to be another bunch of conditions as well. So first of all, let's just try this, and then we can improve this. And I guess we can also we can also like store the indices of the different things. Okay, so also if count is equal to 1, then that means it's also false, right? Because you cannot have like only one different number because you cannot swap it and then get the number. So that's going to be false. And then let's just do like indices of list, and then indices dot append of I, indices dot append. Oh wait, sorry. I guess I can just use this as a counter then. Okay, let's just do that. So instead of adding 1, we'll just check the length of indices. Length of indices. Okay. The length of indices is exactly 1, then it's false. Okay, so now in this case we have exactly 2 indices, right? So we have to make sure if swapping them actually results in the same thing. So, and also like if length of indices is equal to 0, that means that the two arrays are exactly the same, right? That means it's true. So we'll just do that here. So in here, the indices would be exactly 2. So let's just do like if I guess we can extract the indices like this. So if I do this, then the I would be the first index and J would be the second index. And then now we do if I of if I is equal to B of J and I of J is equal to B of I, then that means it's true, right? Return true. And otherwise it's false, I guess. I guess you can do that. So if these conditions are met, then we can swap them and then we can get the answer, right? So otherwise it's going to be false. So let's just do that and see if it works. Okay, it worked. Yeah, let's just submit this. Okay, great. So the time and space complexity of this would be space complexity. We didn't use any extra space, right? We just have like 2 size indices, which is not going to be significant. And the time complexity would be just O of n because we're just looping through the array once, and that's it. Okay. Move on to the next question. You are given an array of integers. On each move, you are allowed to increase exactly one of its elements by 1. Okay, and find the minimum number of moves required to obtain strictly increasing sequence from the input. Okay, gotcha. So basically, the idea is you have list of numbers. You could just keep increasing any of the numbers so that you can have strict increasing numbers, right? So basically this becomes 1 to 3, which means you've used this operation 3 times, okay? So exactly, so it's basically like you just start from the left and then keep on adding the sum, right? So this is pretty simple problem. So let's just start with 0 and then for n in input array. And then I guess we can start from the second one up. Okay, let's just do it with range then. So I range starting from 1 until length of that, right? So I think modifying the array would be nice though. There's no restriction on modifying it, right? So essentially you modify the number as you move on. So yeah, I think modifying is fine. I don't think there's any restrictions on modifying it. Okay, so the idea is if the input array of I is less or equal than input array of I minus 1, then you modify the array, right? So diff would be, so this minus that plus 1. So that's going to be like the difference. And then you just update that input array of I equals, yeah, we could just do plus equals diff. I think that's fine. Or maybe it's going to be, yeah, I think that's fine, right? Let me think. So if the input array minus 1 is greater than or equal to that, yeah, I think that's fine. So I just update the array, and then the s would be just plus minus diff. Plus equals diff. Okay, I think this should work. Let's just see if it does. Okay, yeah, it did work. So the key concept in here is that we have to update the list in order to get the diff that keeps propagated, right? So without updating it, I guess we can also do that. We just have to keep track of the current number, right? So like I guess the previous number, prev number, let's just say 0. And then we can do, I guess also that's a bit difficult. Okay, let's just keep, let's just not do that solution because it's going to be more difficult than I imagined, because you have to keep track of the current number and then do the minimum and stuff like that. I think, or maybe it is that simple. So I think you have to update it here, like else current number, oh no, sorry, prev number that or something like that. So I think that's how it goes. Okay, let's just do that. Prev number is equal to 0, and then else prev number is equal to input array of I. And in here, instead of adding it, we just say prev number is equal to that, I think. Okay, let's just try that. Oh, it didn't work. Why? Return value is 2. Okay. Oh, yeah. So I think instead of doing this, I think this has to be the prev number, I think. Oh, it didn't work. So if the previous, oh, wait. This number is going to be the prev number. Okay. Because that's the previous one, right? Oh, okay. It didn't work. Oh, in here too. I think there just has to be prev. Okay, so if the previous number is, oh yeah, previous number has to be start from the start. Okay, input array of 0. So that's going to be our first previous number. Okay, I think that worked. Nice. Gotcha. Okay, so this solution is going to be like without modifying the input array, and it's gonna be basically the perfect solution to for this problem. Cool. All right, let's move on to the next. All right, what does it say? Given the string, find out if its characters can be arranged into form a palindrome. Okay, cool. So I think on my previous video I used a hash map approach, but let's try to do a what is it called, like a bucket system in terms of letters, I guess, because we have lowercase English letters here, right? So basically we'll just have chars 0 times 26. So we have 26 English lowercase letters, right? So we're just going to count each letters using this array, right? So essentially this means that you have a list of 26 zeros, and then the first place would be count of A, and then second place would be the count of B, and then third place would be count of C, blah, 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 right? So let's just do that. And then in order to know if it's a palindrome or not, after rearrangement is that each character has to be divisible by 2, like each character count, except 1, right? I mean, at most it can be 1. So that's the idea, to know if the rearrangement can be a palindrome or not. So let's just do that. C in input string, okay, and then chars of, okay, so now there's a trick in here, ord of z. So ord would be giving us the ASCII number of the character. Then we can just minus ord of a. So this would give us the appropriate index, and then we just plus 1 here, right? And then let's just do like a count of basically the odd numbers. So for I in range, I guess we could just do for C in chars. And then if C 1, then count is equal to 1. And then if count is more than 1, return false. And then return true, basically, just like that. Okay. Yeah, let's just recap this real quick, right? So this is essentially like the hash map approach, right? So instead of using a hash map, you just do a like a counter characters of 26 size. So what's the advantage and disadvantage of this, right? So if the string has only 1 or 2 letters of the alphabet, then obviously like we're gonna be looping through 26 times, right? But in hash map, you're just gonna be looping through once or twice. So that's the disadvantage basically. But the advantage is that if there are like many characters, then this operation is going to be really fast, because hash map has like a lookup time, insertion time, constant time thing, right? So but in array, it would be much faster, like in a practical sense. And then essentially in here, we're just going to be counting the number of odd counts. And then if the number of odd counts is more than 1, then it's going to be false, because there's just no way to rearrange it so that it can be a palindrome, right? So that's basically the definition of palindrome. Okay, that's that. Let's just submit this. Oh yeah, and the time and space complexity of this thing would be just space complexity is constant, right? Because there's just maximum of 26 sized array, so that's constant. And then the time complexity would be just O of n, which n is the number of characters. Okay, cool. Island of knowledge. Okay, so the first island is done. I guess not the first. What is it called? 1, 2, 3, 4. Fourth island is complete. And then let's just go to the next one. Okay. Oh, okay. This is gonna be kind of ugly problem. I think I kind of remember this problem. All right. So call 2 arms equally strong if the heaviest weights they each are able to lift are equal. Okay. Call 2 people equally strong if the strongest arm are equally strong. Strongest arm can be both right and left, and the weakest, and so are the weakest. Yeah. Given your friend's arm lifting capabilities, find out if you two are equally strong. Okay. So essentially, like the maximum of your left or right hand is going to be 15. Your friends is going to be the same, so it's going to be true. In here, it's also going to be, yeah, true, because 15 equals 15, right? So in here, it's going to be 15. Wait, is it this false? Your left, friends right. Yeah, I guess the minimum has to be the same too, I guess, then, right? Okay. So essentially, like, if max of your left, your right is equal to max of friends left, friends right, and basically min of the same thing, right? So I'll just copy that and then return it. Basically, there's just no need for if statement. It's just going to be like a long condition. So min. That's it. Cool. Right. Yeah, so you can actually do this with a bunch of if-else statements, I guess, but I think this is much cleaner. Let's just do it in one line and be done with it, right? So array maximal adjacent difference. What is that? Okay. Given an array of integers, find the maximal absolute difference between any two of its adjacent elements. Okay, I guess that makes sense. Okay. Max and diff, let's just assume it's 0 at first, and then do a loop starting from index 1 and then goes until input array. And then max diff would be the maximum of max diff, and then input array of I minus input array of I minus 1, but there should be absolute value, right? You can just subtract the two, and then return max diff. Okay, cool. All right, great. Yeah, there's just not much to say about this problem. It's a pretty simple problem. The space complexity is 0. I mean, not 0. I mean, constant, and then the time complexity would be O of n because we're just looping through the array, right? So that's that. All right, cool. An IP address is a numerical labeled assignment device. Yeah, okay. And given a string, find out if it satisfies the IPv address naming rules. Okay. So basically, the rules are there has to be a 4 numbers, right, and separated by dots, and then each number has to be between 0 to 225. So this should be false because there's no number in here, right? And also this should be false because 316 is greater than 255, right? So that's what we're trying to do. Okay. Let's just do this input string dot split by dots. So the dot count has to be actually 3, right? And then the number the parts count should be 4, right? So if length of parts is not equal to 4, then return false instantly, right? Okay. And then we're just going to go through each of the numbers, each of the parts, basically 4 part in parts. And then I think there's a string class called if part is num, I think, but I can look that up, but I'm pretty sure there's there. So if it's num, then let's just do if not num, right? Then return false instantly. If it's not a number, then of course it's going to be not applicable. But if it is a num, then we're just going to convert it, right? So integer part, and then if n is less than 0 or n is greater than 255, return false. Then otherwise, return true. I think these are all the checks. Let's just do that. Okay, so there should is num is not a class. Yeah. Okay. I think it's called is digit actually. Maybe. Let's just try that. Okay. Oh, there's like 0, 0. Okay, yeah, I have to check this one. 0, 1. Okay. Let's do something like if length of part is greater than 1 and part of 0 is equal to 0, then return false. So basically, like if the part is like starts with 0 and also has greater than 1 length, then it's not a valid IP address, right? So let's just do that. Check. Okay, cool. All right. So in this problem, there's just barely any time complexity, right? Because the string number of strings is like, I guess we can say of n because the input string can be really, really long, right? So n is like number of characters. Only 2% of users have solved this question. Okay, sure. Avoid obstacles. Okay, what's that? You are given an array of integers representing coordinates of obstacles situated in a straight line. Assume that you're jumping from a point with coordinates 0 to the right. You're allowed only to make jumps of the same length represented by some integer. Find the minimal length of the jump enough to avoid all the obstacles. Okay. Find the minimum number, right? So the output should be 4. Okay. So you're going to be jumping like with a constant number then. Okay, I guess there's one solution that you can do, which is basically like simulating, right? So um you just start from the beginning basically, hey, can I jump with like 1? Then can I jump with like 2? Can I jump with like 3? And blah blah blah, right? So you can do that. And then essentially there is an answer, right? So because like there is going to be a maximum number, and then you can just jump way past the obstacle, right? And then that's going to be the answer, but that's not going to be the minimum number, right? Because we want to find the minimum. So you can just start from the beginning and do that, and then that's going to be like really really bad time complexity, I would assume. But there is also a another approach where it's technically kind of like binary search, right? So you know the maximum, you know the minimum. So minimum number of jumps is 1. The maximum number of jumps is like the maximum of the obstacle, essentially. And you could just check the middle, and if you can jump on that, then, or maybe it's not that simple actually, because what if you couldn't jump on 5? Yeah, I don't think it's that simple. Yeah, binary search, I don't think it's gonna work. Yeah, it's not gonna work. So essentially, like the only solution is just to start from the beginning and then go up. Okay, so we can be a little bit more intelligent in that, but jump, let's just say starts from 1, then hmm, what should I do? Okay, okay, I didn't know that the obstacles were not sorted, so I think sorting it is actually pretty good approach in here, because like if you want to check if you're on the obstacle or not, I think the best approach would be just to binary search, right? And then to see if you're at the location. Okay, let's just do that as well. But 1, 1, 1, 2, 2. What I was thinking was basically I know that 2 is not going to be the case because it's divisible by 6, right? So I know 3 is not going to be the answer because it's divisible by 3 or 9, or for example, right? So I guess you can subtract some certain cases, but I think we can start from the beginning and then just go forward there. So let's just do like while So I think it's best to like sort the obstacles first. So input array dot sort, and while position is 0, right? And then position is less or equal than input array of -1. So that I think if while its position is less than that, we just keep on looping, right? So essentially, like you do cur position is equal to position plus jump. That's gonna be, I guess we don't need cur position, just say position. Okay, so position is equal to, that's gonna be the current position, and then we just have to check if the position is, within this obstacle, right? So in order to do that, we could just do binary search. So we can create a helper method for that. Do like binary search, right? And then it's gonna be like the input array. Okay, I guess we can just use it here, so you don't have to do that. But there's gonna be a number. So left is 0, right is, this is just standard binary search problem. So length of input array -1. Okay, so while right is less than left, midpoint would be left plus right. Okay, so we're just gonna check the middle and see if that is existing or not. If input array of mid is equal to our n, then return true, right? And elif input array of mid is greater than n. So if the minimum, no, sorry, the mid is greater than our n, then we have to put the right one to the mid -1, because we know that mid is not the answer, right? So we just do mid -1. Then else would be left equals mid +1. So, and then we can just do that. I think this should work. Pause. Then we can just increment the jump and then reset the position. And then you can just say continue, I guess. But if it's found, then we just increase it. But if it's not found, then we just keep on jumping, I guess. Okay, I think that should work. Jump. Okay, let's just try that and see if it works. Okay, it didn't work on some of the tests, or maybe all the tests. Okay. Console output return. Okay, 4. So is it like return value? I guess I'm getting shorted by 1 in here at least. Return value 2, expected value 6. Okay. Jump position. Let's just check check it here. And then do continue, I guess. Okay, that didn't change. Okay. What am I doing wrong here? So we have 2, 3. Return value is 3. I guess this one is not working. So do that, I guess. Okay, yeah, okay. I think I was mistaken to not include the equal sign in here for the standard binary search. Was this gonna work? Let me just check. Okay, yeah, it still works. Nice. Cool. All right. So this question did get solved. Yeah, so there's like some clever ways that you can optimize this, but I don't think it's like not worth the effort. So essentially what you can do is like uh, get all the divisors of all the coordinates and then just exclude that from the jump because you know that's not the answer, right? So you can do that. But I don't think it's that necessary. It's just a really, really small amount of adjustment, right? So you can do that. But in here, the time complexity would be kind of tricky because the sorting is like n log n, depending on the obstacles. But the simulation is going to take the majority of the time, right? So you have, it depends on the maximum of this thing as well. So it can get quite large, the time complexity. Yeah, I don't want to really go into it, but essentially, it can go until this, and then you're jumping in all the time. So I think the time complexity would be really, really complex in here, just to say the least. So it might be even like in the exponential factor. So yeah, let's just move on to the next question. All right, cool. So what's this? Oh yeah, I think I remember this. Okay, so basically it's just the averaging of the pixels, right? Okay, yeah. So essentially you have images, like 2D array, right? Numbers, and then these represent like pixels of the images, and then your job is to average these. I think so. Averaging this 3 by 3 and then put it here, averaging this by 3 by 3, putting here, and then this is the resultant averaged ones, right? Um, so that's the upload, right? So you want to apply box plot and photo hide content. Okay. Pixels in the image are represented as integers. Yeah, every 3 by 3 within the part of moved. Yeah, I return the blurred image as an integer with the fractions rounded down. Okay. Yeah. So that's the idea basically. And then let's just do like result as that. And then whenever there's a 2D problem, I think it's always a good idea to have like a row image call length of image of 0. Okay. And then I think there's going to be like a really cool idea to have a helper function average of like some matrix, right? No, not matrix. Some starting coordinate, right? Like the center coordinate, I guess. I, J. And then you just basically round, sum them up and then round it down. So how should I approach this? I think we can do let's just do X and Y coordinates. And then I in range of X minus 1 until X plus 1, right? So I think it's plus 2 actually, because we wanted to go 3 by 3, right? So for J in range, Y minus 1, Y plus 2. And then there's the sum is equal to 0, and then S is equal to image of X, image of Y. And then return S divided by 9. And then I think there's like a math function, import math dot floor. So we're just going to round it down, right? Okay, so that's the average. And then we just go from the coordinates, right? I in range of starting from 1, then row minus 1, or J in range starting from 1, column minus 1, and then essentially just populate the result. So let's just do like image row is that image row dot append is going to be equal to average of I and J, right? Then keep on appending, and then after the column is appended, then you just append it to the result, right? Image row. Then return the result. Oh, it didn't work. Okay, return value, what is it? 1, 1, it's 7. Why is that? Oh, it's not X and Y, it's I and J, right? Okay. Cool. Yeah, that's about it. So yeah, in this case, the time complexity would be just O of n times n, right? Both of them are going to be the same because we're just going to be doing one loop, and also like the resultant image is going to be the same size almost. So in terms of complexity, I mean. So let's just do that. Okay. Next question. All right. So we have. Oh, this is a Minesweeper, huh? Okay. What is it saying? Game that you have a board with some mines, and those are cells that don't contain the mine, have a number indicates total number of numbers neighboring cells. Starting off with some arrangement of mines, we want to create a Minesweeper game setup, okay? So, what is it saying? Okay, so we have, I guess, two mines in here. Mine. And then these are false, means there's just no mine. And, okay. I guess even though there's a mine, you just still put one. Okay, that's kind of weird, but oh well. Let's just do that. Okay, so basically, like if you haven't played Minesweeper at all, the idea is that these two are mines, right? So this coordinate is a mine, this coordinate is a mine because we have true, true, and then each number represents how many mines are nearby. That includes the diagonals actually. So so you have 8 directions in total, right? So basically, like it can go up to 8. The number. That's the rule. So let's just do that. So yeah, in here, let's just do like matrix, length of matrix. And then call is length of call. And then for I in range, go for j in range, call. Okay, and then I guess there should be a resultant matrix as well. And then row result, just like the previous problem, right? And then row result dot append mine count of I and j. So there's going to be a helper function. Result dot append row result. And then return result. Okay, and then I'm going to do the helper function here, which is mine count. And then this gives me x and y coordinates. And then we're just going to check the 8 edges in total, right? And then count the mines. Basically, count is 0. And then for I in range of x minus 1, x plus 2. So just like before, right? J in range, y minus 1, y plus 2. And then if I is equal x and j is equal y, then we're not gonna count it, right? So because that's the center, we just have to check the edges. So do continue. Okay, so that's the edge case that we can take care of it. And then now we have to check the edges, right? So there are like 8 edges, but we also have to check if it's going to be like index out of bound, right? Because we can have like this corner, for example, and then we have to check 8 edges, but there's no 8 edges, right? In here, there's only 3. So there's going to be like edge cases there. So if you can do like then length of is less than row and j or 0 and then call. Okay, so that means it's within bounds, right? And matrix of I and j is equal it's true, right? So equal to true, but we don't have to write this there, right? So we can just say here and count is increased by 1, then return the count. So that's how you check the edge cases essentially. So without doing any if else statements, like many if else statement. I think this is much cleaner in Python. Okay, I think that's it. Oh, it didn't work. Okay, what is it? Your return value is wrong. Input true. Yeah, mine is obviously wrong. I think the mine count is not working. So, you have row call and row res mine count ij xy. So ij count. There should be some like careless mistake in here. Oh wait, this should be like one tab. Okay, cool. Great. All right, so in this case, the time complexity would be O of n times m, which is the size of the matrix, right? And then the space complexity is also going to be the same because we're introducing like a new matrix, right? So that's about it. Okay, reign of reason. That's the next island. I'm not sure if I can do it under 14 minutes though. You know what? I think this is a good place to stop actually. Let's just do it in part 3 because we already have like 46 minutes, and then I want these videos to be under an hour. So, and then I think this chapter already ended. So let's just end it here and then move on to the and pick this up in the next video. All right, and then if you have any other questions and concerns, please let me know, and talk to you later.